It's good root beer.
I love how every episode starts with us like clearing our throats or having a sip of a delicious beverage, or that one time that I was just like panting and out of breath as I ran into to my desk to start recording.
I hope everybody appreciates that. That way they know we're human and not AI.
Yes, we can promise you that most of the episode is not produced by AI.
Actually, it's true. Most of the wink, wink. We're not AI. Wink.
I was submitting something in an online form yesterday, and there was a bit at the bottom. There was like a bunch of windows to fill in, and there was a point at the bottom that said, "Leave this blank if you are human." And I just wrote in, "Okay." Oh, I almost failed. Welcome, folks. Welcome, gang. Our fellow nerds and scientists and nerd enthusiasts and science enthusiasts and all of you other fine folks tuning in for the first time. Welcome to Science Actually Presents The Nerd and the Scientist. Here today, your regular co-hosts, myself, Kovi Rose, and the one and only Benjamin Salas.
That's me. Hello. Actually, I'm not the only one. I had a really good time a couple years ago finding other people on all social media platforms with the same name as me, and we are now all friends. It's great. So
No,
happy
you have
birthday,
a Facebook.
Benjamin. Happy birthday, Benjamin in France. Whose birthday was on January 2nd.
Wait. This is a Facebook group of everybody with your first and last name?
No, I just friended everyone with the same spelling name as me, and we've been friends for years. It's not many of us, but 7, but it's great. That's
7
great.
Benjamin Salas in the world. Okay.
7 of us carefully placed around the world, just in case. And that's just one classification of human beings. And there are many other classifications. There's Benjamins, there's Kovis. I'm sure there's a Fred out there.
At least one Fred.
At least one Fred. There are other classifications of that's a really crappy segue, but we're going with it. There are other ways, other things that we classify and categorize and organize, like, I don't know, stuff in space.
Space? Huh, what an interesting topic for us to be discussing today. Classifications in space.
Yeah. It's kind of an idea that I bugged Kovi about a long time ago. What's with all the M-class stuff? There's M-class stars, and there's M-class asteroids, and Star Trek there's M-class planets, which is not a real thing. And I was like, what's with all the M's? How come there aren't? How come scientists always classify things with M's? So we looked up a whole bunch of different things that are categorized and classified that are whizzing about out there in space, and turns out there are a great many other classifications.
We should clarify. We did not look up all these classifications. Benjamin diligently, as a responsible adult in this podcast relationship, looked up all of these different classifications. And it seems like today's show is going to be largely somewhat of a quiz to remind me, to humble me and bring me back down to earth. To remind me that just being an astrophysicist does not mean that I know everything, or in some cases anything, about all of the different classifications and classes and subclasses of fantastical objects in space. Benjamin is nodding furiously.
Yeah, so let's put the screws to him, gang. Here he goes. Speaking of classifications and sub-classifications, let's start with planets. There are planets are classified by their mass, or their orbit, or by their composition. And in each of those, there's subclassifications. And well, my favorite one that I came up with, I'm going to try to pronounce it. It's a subclass of planet called, here it's spelled Chthonian. It's a Chthonian planet. A Chthonian planet. Say it with me. Chthonian planet. Kovi, do you know what a Chthonian planet is?
I had no idea until you mentioned it to me. And I was like, is it Chthonian? Is it Chthonian or something like that?
Chthonian.
CH
Yeah.
Chthonian.
Yeah.
I don't know. I didn't know the origins. I looked it up and I saw that it comes from Greek, and I saw the Greek letters, and that's why. Because the only two things that you learn in a physics degree is how little you know and Greek letters, I actually figured out that it is pronounced Chthonian, because in Greek it's spelt with the chi letter at the front, which looks like the letter X. And it comes from the ancient Greek word for earth, I think, kathos. And then it used to, like, chthonic used to have some meaning that was tied to, like, the underworld demons and deities of ancient Greek culture and mythos. But now I know what the science meaning is, which is kind of wild, and I wasn't expecting it.
It's pretty cool. If I'll tell people what it is. It's a planet that used to be a bigger planet. Basically, you have a gas giant planet like Jupiter or Neptune, and it gets too close to its parent star, and large atmospheres don't stand up too well when you're too close to your parent star, and it kind of gets stripped away or blasted away, or just the solar radiation is just too much for a thick atmosphere to handle, and all that's left is the core of that former gas giant planet, and that is a Chthonian planet.
I love it.
It's the beef jerky of planets. Yes. See, like you have a steak, right? You have a steak, and then you put it in the oven, and the heat of the oven is too much, and it or dries it out. It blasts away the moisture, and all that's left is the jerky. See, so the Chthonian planet is like a big juicy steak planet, and it had the atmosphere blown away, and all that's left is the jerky core. So I made that connection. Anybody else hungry?
It's wild. I mean, I love how, like, I had never heard of this before, and my entire contribution to this segment has been knowing Greek letters, whereas Benjamin has given us the astrophysical explanation for how these objects form. But yeah, the radiation of molecules and particles in an atmosphere can give those particles more energy. Basically, there's a transfer of momentum from the photons, the energetic photons coming in from the host star, hitting these particles, energizing the particles, and basically the only way that a planet is able to hold an atmosphere is with its mass. And so basically it's the escape velocity, right? Which is how fast you need to go to escape the gravitational pull of a thing, that determines whether or not these particles will stay there. So basically this radiation is going to come in and give more energy to the particles in the atmosphere, which will allow them to meet or surpass the escape velocity, allowing them to Escape. There you go.
Huzzah!
Science. Yeah, that's a weird one. I feel like there
That's
are
a
going to be a
fun
lot
one.
of these that I don't
It's
know.
a fun one. Hey, Kovs, I love the name. What's the difference between a circumbinary planet and a double planet?
Well, ooh. Okay, I know what the first one is. A circumbinary planet, correct me if I'm wrong, is a planet that's orbiting a binary star system, right?
Right.
So, okay, yeah. So basically, it would be orbiting. Like a binary star system is two stars that don't orbit each other, but they orbit a kind of center of mass
Mhm.
for the system, a central point, and so circumbinary planet would be orbiting that same central point. A double planet, did you say?
Yes, I did.
A double planet. I feel like that would be a system where you have in one orbital path around a star two different planets that are orbiting together. Is that right?
Close. Close. That is a Trojan planet. Two planets that orbit the same two planets on the same orbital path around the same star.
Mm-hmm.
They're a Trojan planet. And so are double planets. But double planets have something else. Very similar to what you mentioned about the binary stars orbiting a center of mass, a point in space between them. So too do the double planets. An excellent example is close is Pluto and Charon. They
Mm.
they orbit a point in space that's either just above the surface or just below the surface of Pluto because they're so similar in size and close enough that they kind of whiz about this central point. So two planets that orbit each other as they go around
Mm-hmm.
uh, a star.
Interesting. So I wonder if all double planets then necessarily have to be, well, at least by like the IAU, the International Astronomical Union's classification, have to be dwarf planets, right? Because a planet by their classification has to have cleared its orbital path.
Right. Right.
Interesting.
Which is a bunch of BS, but whatever.
I mean, it's probably important to mention, especially as context for this episode, that science isn't about getting things right. It's about being less wrong over time, right?
Right.
So
Or
you
correct.
try to just yeah, correct. You're just like we try as scientists to come up with models and theories and explanations and classifications that do a good job of describing the natural world that we can see. And a good job of describing means that we can explain one thing, but also make predictions for other things, and those predictions be accurate. But at the end of the day, nature doesn't always work with our classifications. There are always outliers. There are always things that we will learn later on that kind of fly in the face, no pun intended, with orbital dynamics, but fly in the face of like the classifications that we thought. So it's just like we're doing our best here. So don't be too hung up on like the literal classification of
Nope.
what is a particular thing.
Science is always evolving and making sure it understands things better and better, and has to every once in a while change a line or two in a textbook just to make sure everything is square.
Yes.
Hey,
Exactly.
what's the difference between a rogue planet and an extragalactic planet?
Ooh, I
They're
know
very
this one.
similar. They're similar, but again, different. Same, but different. But still same.
I so Rogue Planet I know is a planet that has been ostensibly ejected from its solar system, or the stellar system in which it formed, and is just rogue. It's not apparently orbiting any star. It's just free floating in space in the interstellar medium within a galaxy.
Right.
Um,
Okay. And then the extragalactic planet.
an extragalactic planet, which I'd not heard of being a thing before, I guess would have to be the same thing, but not free floating in the interstellar medium within a galaxy, but free floating outside of a galaxy. No, wait, not necessarily free floating, or at the very least, it would have to be in a different galaxy, right?
It is not in any galaxy. A extragalactic planet is a planet without a galaxy. It's just some, I guess, must have been ejected from its host star in such a way that it's not just ejected from its host star, but also ejected from the galaxy as a whole.
Hey,
And it's
that's wild.
just out there. I'm sure quite cold.
I can't imagine how we would, with our technology currently, be able to even observe that, right? Because
I believe this is a theoretical concept. I don't know that it's actually been
uh,
pinpointed. But I sincerely doubt it's possible to pinpoint a planet that far away that it's outside of the galaxy. Our galaxy
I mean,
is so immensely huge that we
yeah.
can't. That to see something outside of our galaxy that's smaller than a galaxy is very difficult.
I mean, we can see stars when they explode
Sure,
as
sure.
supernovae outside
Hmm.
of our galaxy, but we can't see stars normally with any like decent resolution, and certainly not planets outside of our galaxy. But that is super interesting. Huh.
Yeah,
Theoretically, be very cool.
theoretically.
Is it that time of the day?
It's
Is it?
about that time.
It's time for an ad break. And just in time, in fact. Are you craving a snack that's out of this world? Look no further than Chthonian Planet Jerky. Packed with bold flavors and otherworldly spice blend, our jerky is a taste adventure like no other. Made from premium, ethically sourced planets, it's the intergalactic snack that'll satisfy your craving. Try Chthonian Planet Jerky today and elevate your snacking experience to a cosmic level. Available now at your nearest convenience store. Chthonian Planet Jerky. Taste the cosmos in every bite.
I love it. I love the sped up legalese at the end of the commercial. I love it.
And just in case folks want, you should be able to find our Chthonian Beef Planet Jerky t-shirts.
Yes.
Where can the folks find them, Benjamin?
Just go to scienceactually.com/store and you'll find it there. Scienceactually.com/store should take you to a Zazzle page with all of our swag, and you'll find that delicious Chthonian Planet jerky shirt, along with a bunch of other things that we've made, about tinfoil hats, stellar sip. Um, we are all recycled star stuff. We got a whole bunch of shirts there.
The bungee cord.
The bungee cord jumping off the flat edge of the flat earth. Scienceactually.com/store. That's a good
Love it.
commercial. I love it.
Yeah.
Love it, I love it, I love it, I love it, I
Cool.
love it. Hey, Cobbs.
Fantastic. All right. Yes, Benjamino.
Oh, I like that. Let's talk about black holes. Can you name the 4 different classifications of black holes? Moreover, what are the classifications of black holes based on?
The properties of a black hole.
And primarily it's
So
their mass.
yes, so it's their mass, their spin, their charge, their electric charge, and the fourth one. What is the fourth one? I know there's the no hair theorem, which the hairiness of a black hole is more of a theoretical thing.
I was just going by the 4 different classifications of black hole mass. I was today years old when I learned about their electrical charge. I didn't know black holes had an electrical
Yeah.
charge.
Um, yeah, as far as I know off the top of my head, I'm pretty sure that those are the three main properties of a black hole: mass, spin, and charge.
Wow. Okay.
What
See?
were you talking about?
Kovi was going on about how Benjamin prepared and he didn't prepare. And then turns out who's been prepared all along? Kovi. Look at that. Astrophysicists are the Boy Scouts of the science world, always prepared.
I mean, I think that most black holes, what you wouldn't expect to have, um, like I think you'd expect them to have a very negligible or neutral electric charge. I think it's theoretically possible, but
Wow.
yeah.
I was going by the different categories of black holes by mass, and the smallest size is called. Do you know what?
Um, I mean, there are theoretically primordial black holes.
That's the smallest one, and
Yields.
they were supposedly happened within the first second or two of the Big Bang, where pockets of material were they didn't have time to become anything yet, but everything was still so densely packed together at that moment that they were able to coalesce and form a black hole that were supposedly anywhere in the range from about 100,000 times less than the size of a paperclip to about the size of the sun or even bigger. That just
That's a lot of paper clips.
That's a lot of paper clips, but everything was so quick and and I'm looking for words. Everything happened so quickly and instantaneously that these itty bitty little black holes that just kind of bubbled up also
Mm,
quickly evaporated as well. Supposedly, that's a
supposedly, yeah.
theoretical. It's a theoretical thing because clearly nobody
I do have
was
some
there to
friends.
record it.
I do have some friends who are working on this exact topic. Maybe
That's
I can try to
awesome.
get them to come in as a guest on the show at some point. Because yeah, it's a really fascinating part of well, there's astrophysics and then there's cosmology, which is kind of on a larger scale. You're talking about galaxies or the universe and the cosmos, but then there are cosmologists who are astroparticle cosmologists who work on like understanding you know, primordial black holes and dark matter and the creation of dark matter and primordial black holes and fundamental particles interactions around the time of the Big Bang. Um, it's super. It's not what I work on, but it's super interesting stuff.
That's awesome.
Yeah.
I don't have friends like that know that kind of stuff. Hmm.
Well, if your friends don't dark matter, and if they don't dark matter, then they're no friends of mine.
I got
I'm
99
sorry.
friends and a dark matter expert ain't one. Anyway.
Sorry for that segue. Yes.
That was great. I like that. That's another t-shirt.
Good. Good tangent. I like it. Anything that produces a t-shirt idea is a good quality tangent.
Speaking of dark, what's a dark nebula? It's a classification of nebula. What's a dark nebula? Since we're talking about dark.
This so this was one that actually tripped me up recently. Um, so I know that there are nebulae that are very dusty, and so at optical wavelengths, there isn't a lot of light that comes out of them. because basically there's so much dust that the light coming from whatever stars are inside of this nebula don't make it out. But if there is a star or multiple stars inside that nebula, when you switched to an infrared telescope, that infrared telescope would show that optically dark nebula to be bright at infrared wavelengths, because infrared telescopes show like the thermal emission of the dust, and the dust would be heated up a little bit by those stars.
So here's my question about that. What's the difference then between a dark nebula and an emission nebula? Isn't an emission nebula something you detect what you just said, the spectral something ultraviolet thingamajiggers? See, I call it thingamajigger because I don't have a degree.
Well, I mean, the ultraviolet emission would be a slightly different process. So I know that an emission nebulae, a lot of the time, what you're seeing is, oh god, how deep into chemistry do we need to go? Electrons orbit a nucleus of an atom at particular levels, and those levels correspond to the energy of the electron. And when you shine a photon of the right wavelength, right energy on that atom, the electron can jump up a level. And when it does that, it basically absorbs the photon, and the electron is higher up. And the same thing happens in reverse when an electron emits. If it's not stable at that level, it emits a photon goes out, and then the electron falls back down a level. So basically, when you have a nebula that has a star or stars inside of it, the photons coming from that star can basically ionize the material around them, meaning that the photons will be swallowed up by those electrons as they jump up a level, and then eventually those atoms in the gas of the nebula will then emit those electrons out. And that tells us about like the chemical composition, obviously, because depending on what the composition is of that gas, that will determine what the atoms are, and what electron levels they have, and the electron levels will correspond to the particular wavelengths of the photons that are either absorbed or emitted. I know that was a lot.
Is that how spectroscopy works? Basically,
That's exactly how spectroscopy works. Yeah, that's how we know if we have a star and that has like a gas cloud passing in front of it. We know what the composition is of that gas cloud because of how there are emission lines or absorption lines that show up in the spectrum.
That's
yeah,
awesome.
it's like a spectroscopy in 1 minute.
I don't think I could have handled the second one. That was great. Spectroscopy.
Spectroscopy in 2 minutes? No, too much. 1 minute?
No, that's ridiculous. 1 minute? Let's do it.
Do we have time for one more classification? Assuming that I answered that question.
You answered that one great. So many to go through.
So many choices, so many things in space, infinite cosmic things.
So many things. Let's talk quasars.
Oh, quasars.
There are several kinds of quasars. My favorite. They all have really cool names. Radio loud, radio quiet, broad absorption lines, type 2, optically violent, weak emission, and then this one, they just called it red. Just red. Red quasars.
Red.
Why do red quasars simply have their name red instead of something cool? What makes red quasars red? Or called red, rather?
Interesting. I would... I mean, I think a lot of the nomenclature and classifications around quasars generally, like I was saying before, is just due to like empirically we observe things and we're like, oh, that's slightly different. Let's give it a new category. But in reality, most quasars are not fundamentally different. They're just we just observe them differently. So like a radio loud versus a radio quiet quasar might just depend on when we're looking at it and the angle at which we're looking at it, and a whole bunch of other things. So red quasars, I would imagine, might be quasars that have a very high redshift, meaning these are quasars that are very old and are far away from us, which means that because of the expansion of the universe, the light coming from them is redshifted significantly. That would be my guess. I don't know.
Red quasars are quasars with optical colors that are redder than normal quasars, thought to be the result of moderate levels of dust extinction within the quasar's host galaxy. Infrared surveys have demonstrated that red quasars make up a substantial fraction of the quasar population. I love that
Population.
That's
Interesting.
cool.
Yeah.
Yes.
So they're optically redder. Okay. Huh. Fun fact.
I like optically violent variable quasars because it sounds like you're gonna die if you observe one. It's a radio loud quasar in which the jet of the quasar is directed directly toward the observer, and that sounds like I'm gonna take a wild guess. That sounds like a blazar.
I was about to say that sounds like a blazar. Yeah. Nice.
Man, I love reading all these things. I get things right.
Thank you you basically defined academia in a sentence. Oh, that's great. I think we might be out of time, but I'm having
I think we're out
so
of
much
time.
fun.
But this was fun. That was a good time ping ponging around this ridiculously long list of stellar classifications. We didn't even touch upon galaxy classifications or moon or asteroid classifications or comets. We didn't talk about this one classification of comets called lost comets.
Lost comets. Yes, Peter
Lost
Pan and the
comets.
Lost Comets.
Just lost comets. I had it. I had a comet. It was in my pocket. Now it's lost.
Oh, must have a comet-sized hole in your pocket.
We should do a comet episode. That'd be fun.
You know what? Yeah, I mean, a lot of the history of classifications is, well, especially with extragalactic objects, goes back to the 18th century with Charles Messier, and he was basically classifying things without knowing what they were, but basically just saying, this is not interesting, it's not a comet, all I care about is comets. But that maybe is a story for another episode.
All right, I'm down. There you go.
Love it.
Cool beans. Hey, everybody listening. Can I just say thank you for listening? Thanks for listening.
But seriously, thank you all. It's been lovely seeing our audience continue to grow with more listeners popping up all over the darn place.
Yeah.
It's nice.
We have everywhere. We've got listeners all over the US and Central America and Europe, and we saw 2 little blips pop up in Israel, and Australia looks on our little map of listeners is starting to get a little series of bumps in the southeast. It's very exciting.
A couple of places in China. We have a listener in Japan. It's wonderful. It's really great.
Love it. I love it. I don't have to wait for someone to maybe give me stats. We just have them now. It's a sore point, but a good one.
Well, thank you all again. You have been listening to Science Actually Presents The Nerd and the Scientist. Benjamin, where can the good people find you?
Everybody, you can find me and all my SciComm doings on the internet.
Great answer. You can find me
Yeah,
on the internet as well.
where on the internet? You can find
Ah,
me. Look up Science Actually on all the social media platforms. Science Actually is biggest on Facebook, but we're also on Twitter, Instagram, Threads, TikTok, Hive, Mastodon, Tweet. Did I say Twitter? Twitter again. Why not? LinkedIn. We're everywhere. And also, don't forget to go to scienceactually.com/store to get yourself a handy dandy T-shirt.
yes, one of
How about
those
you, Cubs?
lovely
How about you, Cubs?
limited edition Chthonian Planet Jerky t-shirts. I'm going to be getting one in every size. Um, I don't know why, but I want one in every size. And folks can find me and all of the science posting and meme posting that I do on the interwebs at Fun Fact Science on all good social media platforms. If there is such a thing as a good social media platform, you can find me on Facebook, Instagram, the artist formerly known as Twitter. LinkedIn, TikTok, probably forgetting other ones. But yeah, look us up there. Let us know in the comments what you thought of this episode. We're accepting positive feedback, constructive feedback, and absolutely no negative feedback at all. So don't even
None.
bother. None,
Don't
not
even.
even a little.
No.
No,
Don't
just
even want to hear it.
take no negative energy. None of those
Don't want to hear it.
vibes. Don't want to hear it.
Nope.
And we will see you next time on Science Actually Presents